first let's look at a word problem where the function is in vertex form. The high school robotics team designed a robot to toss t-shirts for sporting events. At the current power settings, they calculated the path of the t-shirt tossed from the robot can be modeled by this equation, where x is the horizontal distance in feet and y is the corresponding height in feet. What I love about quadratic word problems is that they usually give you the function. You just have to think about which form did they give it to me in, and what does that form tell me? How do I find the vertex? Because this is the path of a parabola, so that's the t-shirt being launched from that robot. And what it doesn't really tell you is that it starts here at 0, 0. Vertex form tells us the vertex. So according to that equation, who's brave and wants to pick out what the vertex is? 2618. 2618. X is the horizontal distance in feet. That means that to get to this vertex, you go 26 units in and then 18 feet up. So the first question, how far can the robot toss the t-shirt? Well, yeah, if this first part's 26, you know that a parabola is symmetrical, so that means this over here is also 26. 26 and 26 is 52, so 52 feet. What is the maximum height of that tossed t-shirt?
18 feet.
18 feet. Do you see how the only math that we've really done is 26 times 2, or 26 plus 26? Okay, next, if a fan is standing 23 feet from the robot on flat ground, would it be possible to catch the t-shirt? Why or why not? So if we just look at this picture, 23 feet would be like at this orange dot. Does it look like the height would be doable at that point? Maybe. Let's see what the height actually is. If we want to know what is the height of the t-shirt 23 feet away from the robot, we need to plug in x equals 23. So we would do y equals negative 0.02663 times 23 minus 26 squared plus 18. Type that into your calculator exactly as you see it. So 23 feet away from that robot, the t-shirt would be 17.76 feet high. Those of you who play basketball, how high is the rim of a basket? Isn't it 10 feet? I think it's 10 feet. Wow, we know a lot about sports, don't we? There's a lot of sports people in here. Go sports!
I run cross country.
Sports ball! Yeah,
It's 10 feet.
I think it's 10 feet. I'm pretty sure it's 10 feet. So NBA players can jump and dunk and get a ball through a basket that's 10 feet high. Do you think it'd be possible to jump to catch a t-shirt that is 17.76 feet in the air?
No. I mean,
Yes.
it depends on how.
On this question, your explanation for why or why not would have to be very solid.
All right,
So I would say no, because the shirt is over 17 feet high at that point. Now, if you have some crazy description about like, this fan happens to be an alien with like trampoline feet or something crazy, if your explanation adequately accounts for 17 feet in the air plus. Okay, fine. But your explanation better be pretty darn entertaining. I mean, good, solid, mathematically, entertaining. All right. So what I really want you to get from this problem is we did not do a lot of math. They gave us the equation in vertex form. We picked out the vertex. If you know the vertex, you basically know almost all of the information that you need to answer these questions. The problem is when they give you an equation in standard form. And unfortunately, this equation broke over the line. So if you want to rewrite y equals on the second line so that it makes that equation complete. Now, we graphed standard form. We do know how to find the vertex in standard form. So if this is our vertex, we need to know the x value and the y value of our vertex. To find the vertex, we need to first find the axis of symmetry. Do you remember the formula for axis of symmetry? Opposite of b over 2a. This class knows it. So our opposite of b would be negative 0.7. 2 times a is negative 0.01. It is important that you do 2 times negative 0.01 first before you do the division. Okay, and then we do negative 0.7 divided by negative 0.02. That axis of symmetry tells us that the first part of our vertex is 35. How do we find the rest of our vertex? Plug in 35. So we need to do y equals negative 0.01 times 35 squared plus 0.7 times 35 plus 6.
It's L1 equals 0, 1.
I got that in there, I think, didn't I?
No, never mind, you did. That's
Okay.
fine.
I love it when my students are watching so closely that they find errors, because I often will type errors, type it in wrong. Did you get 18.25? Sure.
Yeah.
So when you plug in 35, that gives you 18.25. So we now know the horizontal distance away from the thrower that the vertex is and the vertical distance. So the first question, what is the maximum height of the shot put? Well, 18.25. I don't know if you can see that over the trees. 18.25 feet. Remember that that maximum height is the y value of the vertex. Part B says approximately how far from the shot put thrower does the shot put land? Well, from the thrower, this is 18. So since it's symmetrical, we know this is also 18. Sorry, not 18. See, nobody's paying attention. We need to... 35 and 35. What is 35 plus 35? 70 feet. Now the question, why is the word approximately used? Check out where this shot put starts. It starts from where the shot put thrower's hand is, which is our y-intercept. Remember, your c value is your y-intercept. This shot put starts 6 feet in the air. So over here, when the shot put is again 6 feet in the air, that's where that 35 feet from the max to that point would be. It goes a little bit farther before it actually hits the ground. So it would actually be more like 70 71, 72. It's not quite perfectly 70 because our parabola didn't start at 0, 0. In this first one, the parabola started at 0, 0, so it accurately tells you that whole length. This is a great time to remind you that this C value is your y-intercept. That's the starting point of the object that is being tossed, thrown, launched, whatever. Okay. Example 3 is in intercept form. The robotics team modified some settings on the t-shirt throwing robot, and now the path of the t-shirt can be modeled by this equation. X is still the horizontal distance in feet, and y is the corresponding height in feet. So if we look at a picture of this, it won't let me erase. How far can the robot now toss the shirt? Well, first we have to think about that this is intercept form. What does intercept form tell us? Tells us our x-intercepts. What are the x-intercepts? 4 and 22. I just realized that's awfully thin. There we go. So at 4 and at 22, that is going to be the path of that t-shirt. So we actually don't need to do any quadratic math to get part A. How far can the robot toss the shirt? If the shirt starts at 4 feet and ends at 22 feet, how many feet happens between 4 and 22?
18.
How did you get 18?
Yes, ma'am.
22 minus 4, 18 feet. There are 18 feet in between 4 and 22. What is half of 18?
13.
9. And 4 plus 9 is 13. So halfway between 4 and 22, this point is going to be 13, comma, something. How do we get that something? Plug it in. So 13 is halfway between 4 and 22. Plug in 13. The maximum height of the tossed t-shirt is 24.3 feet. If you have your vertex and you sketch out a little picture, you basically have all of the information that you need. So each type that you are given, check to see what is my vertex. If I don't have my vertex, how can I find my vertex? Those of you who are not in class, when you have tables of values, it kind of explains this in the notes. But if you find the differences in the y values, notice here we found the difference between 26 and 74, that was 48, 74 to 152, that's adding 78, and so on. Those are not the same. If that first level of differences is not the same, then these points, if you plotted them on a graph, would not form a line. So it's not a linear function. The interesting thing is, if you look at the second level of differences, between 48 and 78, we're adding 30, 78 to 108, we're adding 30. Because that second level of differences is the same, that makes it a quadratic function. That means if you plotted these points, they would form a parabola. In B, notice the first level is the same. That means they form a line. They are linear. In C, the first level is not the same. The second level is not the same. So not linear, not quadratic. Actually, the pattern repeats itself. This would be a case of neither.